Viewsonic VP2130b 2130b 21-inch monitor, and it is not working. Power light does not come on. Monitor appears to be essentially completely dead. I've worked on these monitors in the past. It's usually bad capacitors, and it's usually the same usual suspects. Very typical of any sort of consumer electronics built in China or Taiwan between 1999 and 2007. I would say the majority of electronics made in those places during those years have bad capacitors. Anyway, we're going to open this thing up and see if we can't find the problem and fix it. Now we have flipped the monitor over, exposing the back. There are 4 screws holding the back on. 1, 2, 3, and 4. I've already gone ahead and removed those 4 screws. Then you have the next thing, you have to pry this, you have to pry the bezel off between the back and the front. This bezel is kind of thin, so when you're digging your screwdriver underneath there, trying to pry it off, be careful because you can crack it real easy. I have started along the top. I've already got it partially opened. Popping these things out again. Be careful not to crack it. And you just work your way all the way around. Be careful on the bottom because that's where the button board is, and you could damage those buttons. Now the bezel has been completely loosened. The button board is connected to the circuit board, really. So really what you want to do, at this point you want to place it back on its face and lift the back off, because you don't want to damage this cable and this button board. Okay, now we have the back off. We're going to start. We need to expose the electronic boards underneath this board carrier. We're going to start here. The inverter is located underneath this shield. There's 2 screws here and here, and with those removed, that shield will just come right off. Okay, just remove the screws and off comes the shield. Then we have the screws that hold in the VGA and the DVI connectors. We're going to go ahead and remove those. Next, we're going to remove the cable that goes to the button board. Now this connector here is really delicate and it breaks very easily. Just sort of get your fingernail right underneath it here and sort of flip it up, sort of like that. And then this should just slide right out. Then we're going to go ahead and remove the inverter. There's 4 screws, 1, 2, 3, 4, and then 4 connectors supplying the backlights. Okay, I've gone ahead and disconnected these connectors, and I've removed those 4 screws. Now, at this point, the board just slides out. Now, there's a connector here between the inverter board and the power supply board inside, right there. But you just slide it back and up. Okay, it's out, and there we go. Now, I can tell you from experience, a very common fail in this monitor are these capacitors right here. Four screws holding on this board carrier. The other boards are underneath this, what I would call a board carrier. We got well, these 2 screws were already removed to get the shield off. Now there's 2 more screws over here. Now I've gone ahead and removed these two screws, and now this whole assembly should now be loose. And we can now flip it over. Now that we have the board carrier flipped over, we've now exposed the power supply board, the main board, and then here's a little satellite board off the main board, which handles the, it's got a USB port multiplier. So we're going to go ahead and remove 4 screws holding on the power supply, 4 screws holding on the main board, 3 screws holding on the satellite board. That should loosen up everything. Now I've gone ahead and removed those 11 screws. Now I'm going to go ahead and separate these. The power supply will be removed first, disconnected from the main board. Okay, there's the power supply board. Quite a bit of discoloration in there. You can get some idea that that's pretty hot. Now the main board is connected to the panel with this cable. This cable is a bit hard to get off. You have to sort of work it back and forth. It's on there pretty tight. Okay, and now this has been loosened and we can take that off. You can actually separate that satellite board as well. Now we'll look at them more closely. Now that I've got this board out, one thing that's apparent, somebody had this before me. Somebody tried to fix this before me, and you can see these 3 caps here. 1, 2, 3. Somebody's already replaced those. So somebody already had a go at this before me. Apparently they were not successful. They probably just saw that those caps were swollen and just went ahead and replaced them. And yes, and having worked on these monitors before, yeah, these caps will go bad, and when they do swell. Since I have worked on these monitors before, I knew something that whoever tried to work on it ahead of me didn't know. These little fat little capacitors here, these capacitors are 330 microfarad, 16 volt. Got one here, you got one here. And we had 2 here. I just pulled these 2 out. You know, I desoldered them. And I checked them with my handy dandy capacitance meter. And they're reading essentially 0 capacitance. So that's part of the problem. All of those little caps, these guys here, they're going to have to be replaced. Again, somebody had already replaced these 3 caps. I went ahead and replaced this, this, and this. These all measured really bad. And I knew that from past experience dealing with this particular monitor. Also, I have benefit of a capacitance meter. So if you're going to do this kind of work, you really got to get one of these, because they look perfectly normal. But the capacitance meter tells me that they're bad. Now we move on to the power supply board. And something I noticed, it looks like there's some material dripping out of this capacitor lead right here. I've seen these caps go bad. It has this insulating plastic on it. I'm going to have to remove this in order to gain access to that capacitor. I'm going to go ahead and desolder the big capacitor, and check it on the bench. Okay, now I went ahead and desoldered the big 400 microfarad 150, 150 microfarad 400 volt cap. It looked bad when I tested it in circuit, but just to be 100% sure, I went ahead and pulled it out of circuit and see what we've come up with. Nothing. It's not even seeing it. It's an open circuit. Okay, so clearly our monitor would never work without this guy. This is probably the single biggest problem, so we'll need to replace this guy as well. Okay, here's our power supply board with the new 150 microfarad 400 volt capacitor. And here's the old one, and totally bad. You see some stuff leaking out of it right there. Now the thing about this capacitor is it's only 37 millimeters long. Those are kind of hard to find. Okay, typically they're going to be, this 400 volt 150 microfarad. They're typically going to be like 42 millimeters long, and they just won't fit because this guy's in the way. One little caveat about the VP2130b monitor. There's two different versions of the power supply board, similar but slightly different, particularly up at this end. You notice there's different capacitors that are arranged differently. Also, there's a different connector. One version has this connector, another one has a 6-pin connector that plugs in right there. Now, this one comes out of a monitor I just got that's blown, that's not working. Anyway, here's our friend, big C1, 150 microfarad 400 volt cap. On this one, you can see it's really swollen at the end. The other thing you can probably appreciate is all that yellowing all around this whole area. This thing has gotten very, very hot. It's gotten so hot, in fact, that you can see the plastic coating on the capacitor is actually it's actually rippled. Okay, and I've seen that before with these. As the ESR builds up, as the resistance builds up, these things can become very hot. And that's what's happened here. And of course, it's swollen and now it's failed. But anyway, again, just be aware that there are two different versions. This one is the later version, I believe, yes. This one is the EADP64BF. This is the EA64CF. And this one I've already replaced the capacitor. This is not the original cap. This is a replacement cap. Also, this capacitor was replaced. So any of these caps can go bad. And this one almost always goes bad, but any of these can also go bad. Usually these will swell when they go bad. Remember, we pulled this shield off the power supply board in order to gain access to this capacitor. Remember to glue it back on. I assume they put it there for a reason. We don't want to have any short circuits later on down the road, so I like to use this stuff. This is pretty good for this kind of work. Okay. Also on the inverter board, these three caps here, again, maybe you can appreciate those have been resoldered. It appears that these three caps have also been replaced. So again, from past experience, these caps do frequently go bad, and when they do swell. So somebody got here ahead of me trying to fix this thing. Okay, with all those parts replaced, I'm going to go ahead and reassemble this thing and see what we got. Okay, we begin by reconnecting this connector between the main board and the panel. And this is keyed, by the way, so it only goes in one way. And then we flip it over and line up all these connectors. Next, we reconnect the main board to the power supply board. And drop it into place. Now we've got to put the screws in. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3. Now with all the boards screwed back in, we're going to go ahead and flip this over. And put the inverter board back in. There's a connector between the power supply board and the inverter. Slide it into place. And now we just simply reconnect all of these cables. Gotta get them in that little slot there, otherwise you're not going to have enough room. And we've shifted the position of this board carrier to line up all the holes. Now we can go ahead and reconnect our inverter. Next, we got the 4 screws in the inverter. Put those in, and the shield over that. And then 2 screws here and 2 screws over here. Now we have to connect this cable. Okay, this has been snapped back into place. Again, very delicate connector there. Be real careful. You get your fingernail under it this way and you pop it open this way. And you snap it back down. Real easy to break that. And then the screws holding those VGA and DVI connectors in. Okay, everything's been put back in place and all the screws, everything's been secured. I think now we are at a point where we can go ahead and test it with a video source and a power supply. Okay, we now have the power cord hooked up and a video source hooked up. Now, one thing about this monitor to remember, there is a power switch on the back. Okay, so make sure that that's turned on, because if it isn't, nothing's going to work. And we're going to go ahead and hit our power switch, and yes, it's working. How wonderful. Okay, so we brought this nice 21-inch 4:3 aspect ratio monitor back to life. And by the way, this is 1200 by 1600 resolution, which is really pretty nice. Personally, I prefer the 4:3 form factor. I think it's better for doing work. I really don't care for these really wide monitors. They're great for watching high definition movies, but not for doing work. Okay. Now, somebody tried to fix this before me, as we saw. There were several capacitors had been replaced. Whoever got here ahead of me simply replaced the capacitors that looked bad, the swollen capacitors. So without benefit of a capacitance meter, he couldn't find the other bad capacitors. So He was so close, but so far. So we found the rest of them, we replaced them, and got ourselves a nice working monitor. Okay, that's it.